Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 17, Sampling Variability. Classwork. Example 1, Estimating a Population Mean. The owner of a gym the owners of a gym have been keeping track of how long each person spends at the gym. 800 of these times in minutes are shown in the population tables located at the end of the lesson. These 8 times will form the population that you will, these 800 times will form the population that you'll investigate in this lesson. So remember, a population is all the data. Look at the values in the population. Can you find the longest time spent in the gym in the population, and can you find the shortest? So we need to go to the end. It is at the back of your, so there's the population, continued, and table of random digits. So we have a population here on one page, and these are the number of minutes, and they name the rows and the columns. All right, so 45, 50, 47, here's 78. So I'm just looking for the biggest number in each row for starters. And so 78 is the biggest so far. Now 83 is, so that's not the biggest. And I'm just looking for larger numbers than 83. There's 83 again. And we're just looking for the biggest number. Here's a 92. So now we're up to 92. And we just continue this process, looking for the largest number. La-di-da. Not very exciting, but it is statistics. And as we continue, not finding, here's a 92 again, but that's what we already had. And I'm not seeing any 3-digit numbers, so we don't have any hundreds of minutes. So it's looking, I'm not seeing anything bigger than 92. So then I go on to the next page. And remember, 92 is our biggest number so far. Here's a 21, by the way, because we do have to go to the shortest. Here's an 11. And we might as well do 2 at the same time. So 92, I'm still looking for a number greater than 92. And I'm not seeing any 3 digits anymore. Or again, here, I'm not seeing any 3 digits. So, okay, so anyway, I perused this data. I'm back on the first page of these. And I did find 92, I think, is the largest, and 11 is the shortest. I looked on the first page again for shorter than 11. I don't see any single digits. So if I go back up to the first page, where it says, can you find longest time spent, 92 minutes, shortest time, 11 minutes. On average, roughly, how long do you think people spend at the gym? In other words, by just looking at the numbers in the 2 tables, make an estimate of the population mean. So then we go back to that table, and we're just going to estimate the population mean. So I'm seeing a lot of 40s, a lot of 50s, 60s. Here's a 16 that would drop the mean. So I would probably say that the mean, I would estimate the mean to be about, I would guess, 50. So that's my guess. It doesn't mean that yours has to be the same. And I would say that it'd be approximately 50 minutes. You could find the population mean by typing all 800 numbers into the calculator or a computer, adding them up and dividing by 800. This would be extremely time consuming, and usually it is not possible to measure every value in a population. So we're leading up to something here. Instead of doing a calculation using every value, we will use a random sample to find the mean of the sample. The sample mean will then be used as an estimate of the population mean. So example 2 says, selecting a sample using a table of random digits. The table of random digits provided with this lesson will be used to select items from a population to produce a random sample. The list of digits is determined by a computer program that simulates a random selection of digits 0 through 9. Imagine that each of these digits is written on a slip of paper and placed in a bag. After thoroughly mixing the bag, one slip is drawn and its digit is recorded in a list of random digits. The slip is then returned to the bag and another slip is selected. So it's choosing with return, okay? The digit on the slip is recorded and then returned in the bag. The process is repeated over and over. The resulting list of digits is called a random number table. How could you use a table of random digits to take a random sample? Step 1, place the table of random digits in front of you. Without looking at the page, place the eraser end of your pencil somewhere on the table. Start using the table of random digits at the number closest to where your eraser touched the paper. This digit and the following two specify which observation from the population table will be the first observation in your sample. For example, suppose the eraser end of your pencil lands on the 12th number in row 3 in the random digit table. 12th number in row 3. So let's take a look at that. So here's our table of random digits. 12th number in row 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what they're saying is you put your pencil's eraser down on this piece of paper here randomly, and it was on this 5. Okay? All right, so that's where we're at. And it says here, this number is 5, and the two following numbers are 1 and 4. So if I go back to that circled, the next two numbers were 1 and 4. Okay, what does that mean? This means that the first observation in your sample is observation number 514 from the population. Find observation number 514. By doing this, go to row 51 and move to column 4. So I'll go to this. 51, 1, 2, 3, 4 is right here because there's a 0. There's 500, 510, 11, 12, 13, 14. And the number was 53. So that's how we're doing this, okay? And the number's 4. This observation is 53, so the observation of your sample is 53. If the number from the random number table is any number 800 or greater, you will ignore this number and use the next 3 digits in the table. So if you draw an 8 or a 9 first, disregard, start over, right? Can't have anything over 800. So you could draw an 8 and then 2 zeros. So you don't just disregard the 8. But if you draw a 9 first, put it back in the bag, don't count it, start over. Okay. Step 2, continue using the table of random digits from the point you reached and select the other 4 observations in your sample like you did in step 1. For example, continuing on from the position in the example given in step 1, the next number from the random digit table is 716 and observation 716 is 63. So let's just say you drew a 7, a 1, and a 6. So you go to 716 on the table. So in other words, you drew a 7, then a 1, then a 6. Okay, so how is that working? For example, continue on from the position and example start in step 1. So what was step 1 again? I'm just revisiting this, making sure we get this. Okay, so you put your pencil down on the paper, on this paper here. So obviously they landed on $716. How did they get that? 7. So to get the 716, they drew a 7, or they put the pencil on the 16th column in the 7th row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that was the 2. So the next two are 2, 3, 1. So then we go to the next page, or the previous page, find row 23, and 1 is 48. Okay, so see if that's what they have here. So 716, observation 716 is 63. The next number from the random digit table is 565. So they got 716 is 63. Okay, so they're just telling us what the three numbers they did. So they didn't do 7, 1, and 6 to get to 231. They found 716, like right here. So they had 19 and whatever, and 716 is 71, and 0, 1, 2, 3, 4, 5, 6 is 63. Okay, all right. So the next number from the random digits table was a 565, and that gave us 31, and so on and so on, and so they found these numbers. So that's how you find your sample of however many they asked for. So exercises 1 through 4 says, initially you will select just 5 values from the population to form your sample. This is a very small sample size, but it is a good place to start to understand the ideas of this lesson. Use the table of random numbers to select 5 values from the population of times. What are the 5 observations in your sample? Okay, so if I did this randomly and I just move my mouse around and then just click somewhere, okay, so I chose that 9, so I want 955. That was my first sample. So then I go back and I go, and remember, it started with 9, so what do? It only goes up to 800, so I would disregard that. So I'd try again, erase that, and try to put my pencil down on something that's not a 9 first. And here we go, randomly I chose 827. Not doing very well, that's higher than 800, so let's try again. There's a 3, 335. So then I go back here, and I look for 33. Let me erase all this. So I go to 33, which is right here, and 0, 1, 2, 3, 4, 5. So there is my first. So I have 55. Now I do it again. Actually, let me erase all this so there's nothing here. Okay, random sample again. I got 408. Go back to 408 is 46. I'll write these all in the same place on this paper. I got 46. Okay, go back to here. Randomly put your pencil on, and it's 112. So I go to 11, 2. 11, 2 was 56. Okay, and then randomly, boom, right here, 310. So I go back, 310, it's 30, 1, 0, which is 84. And I do this one more time. And I chose this one, which is right here, and I can't read that because I covered it. It's 055. So I go back to 0, 5, and 5, and it's 69. So then I find the average of these. Okay, 6 and 5 is 11, 6 and 4 is 10, that's 21, and 9 is 30, carry the 3, 5, 8, 12, 17, 17 and 8 is 25, plus 6 is 31, 310 divided by 5, and that'd be 6 times 5 is 30, subtract it 10, and I get an average to be 62 minutes. So my mean is 62 minutes. Okay, so it said use the table of random numbers to select the 5 values of your population of times. What are the 5 observations in your sample? So there they are. And it says for the sample that you selected, calculate the sample mean. I already did that on the previous page. It came out to be 51. And 3 says you selected a random sample and calculated the sample mean in order to estimate a population mean. Do you think that the mean of these 5 observations is exactly correct for the population mean? Or could it be greater than the number you calculated? Could it be less than? Okay, so since this is just a sample, of course it's not going to be exact. And my X bar could be less than the actual, my estimated mean could be less than the actual, but it could also be greater than the actual. So it could end up anywhere, but I would assume that if my sample size is a decent amount, usually it's 30 or more, to be accurate, then I should be close to the actual mean, but not exact. Number 4 says, in practice, you only take one sample in order to estimate a population characteristic. But for the purpose of this lesson, suppose you were to take another random sample from the same population of times at the gym. Could the new sample mean be closer to the population mean than the mean of these 5 observations? And could it be further from the population mean? So what they're saying is, if we had this here and the actual mean, X bar, the population mean, that's the mean of the population. In practice, I only take one sample in order to estimate a population characteristic, but for the purpose of this lesson, suppose you were to take another random sample. So say my population, my mean ended up here, and I'll call it X bar sub 1. What this is saying is, could the new sample mean be closer to the population mean than the mean of these 5 observations? So could I come up with a mean on my second try that's closer? Or could I come up with a mean that could be way over here maybe, which is a bigger distance than this, and it doesn't have to be less than, it could be on this side, and say it was over here, and that could possibly be my mean over there. That's what this question's asking. And of course it could be less than or greater than, because again, we're just doing a sample. Okay, so exercises 5 through 7. As a class, you'll now investigate sampling variability by taking several samples from the same population. Each sample will have a different sample mean. This variation provides an example of sampling variability. So 5 says, place the table of random digits in front of you, and without looking at the page, place the eraser end of your pencil somewhere on the table of random numbers. Start using the table of random digits at the number closest to where your eraser touches the paper. This digit and the following 2 specify which observation from the population table will be the first observation in your sample. Write this 3-digit number and the corresponding data value from the population in the space below. So I will do this as well. So what they're saying is, come over to this page here, okay, and I am going to now obviously I do not have the whole thing on the page, but if I do this and then boom, I chose that, then it's 449. So then I go up here, and 449 is 38. So that's what they wanted you to do here. So 38. Continue moving to the right of the table of random digits from the place you entered or ended in exercise 5. Use 3 digits at a time. Each set of 3 digits specifies which observation. Continue until you have 4 more. So now what they're saying is, instead of just putting the pencil down, you go to here, and my next observation is going to be 873. That's more than 800. I can't use it. 438 is my next one. So then I go to 438, and that is 67. And I write it here. Okay, you get the idea? And then I go back to here, and the next one is 291. Go up to 29.1, and that is right here, and it's 42. And we have to do this 4 times, so I have 2 more times. So I come over here. Next 3 is 538. So 538 is 80. I'm going to do one more time. And that is 989, but it's too big. So I go 296. So 296, 0, 1, 2, 3, 4, 5, 6 is 41. So there are my 4 more. Calculate the mean of the 5 values that form your sample. So I have 38, 67, 42, 80, and 41. 8 and 7 is 15, 16, 17, 18, carry the 1, 3, 4, 10, 14, 22, 26, divided by 5. Five times 5 is 25. 5 times 3 is 15. And I get 53.6. So my mean is 53.6. Okay, exercises 8 through 11. You will now use the sample means from exercise 7 from the entire class to make a dot plot. All right, obviously I can't do this because I'm not in a classroom setting here, but we've made dot plots before, and I can give you a sample of what it would look like. Okay, so I came up with these values here. Let's just pretend that I have a class of 10, and these are their 10 outcomes. So it says write a sample mean for everyone in the class in the space below. So there's the sample mean of all 10 students in my pretend class. Number 9, it says use all the sample means to make a dot plot using the axis given below. Remember, if you have repeated or close values, stack the dots one above the other. 68.4, so that would be about here. 67.3, which would be here. 44.4 is here. 55.4. So that'd be about here. These are all 1 increments. 52.2 would be here. 62 is right here. And 41.3 is about here. And 50.2 is here. 69.9 is almost 70 right there. And 46 is right here. Okay, so there's our dot plot. What do you see in the dot plot that demonstrates sampling variability? Okay, so here's a sample response. The dots are spread out, indicating that the sample means are not the same. The results indicate what we discuss as sampling variability. Okay, so just because it's a sample does not mean it's going to be that accurate. Number 11, remember that in practice you only take 1 sample. In this lesson, many samples were taken in order to demonstrate the concept of sampling variability. Suppose that a statistician plans to take a random sample of size 5 from the population of time spent at the gym, and that he will use the sample mean as an estimate of the population mean. Approximately how far can the statistician expect the sample mean to be from the population mean? Okay, so there's many answers to this question. As a student, you may think that the sample mean is exactly the same as the population mean, and therefore the distance, or how far the statistician the mean would be from the population mean, would be 0. Or if you were looking at this dot plot, you might think the population mean would be somewhere smack dab in the middle here, and if your sample was here, you might say, well, it's off by 2. But if your sample was over here at 67 or 68, and it was actually 54, then your distance could have been as much as 14. Okay, so it all depends on how you look at your sample and how you interpret what your value is, what a particular mean might be compared to the population mean. Okay, and I believe that is the end of lesson 17. Review the lesson summary and go do your